Morning, everyone. So what we're going to do today is we're going to look at a skill going forward and backwards with a skill. We're going to ask you to solve for the roots given a factored polynomial, and then going backwards, given the roots, write the factored polynomial. So we're going to go both directions. So if I give you a function, and let's say the function is very broken up here, as you guys can see, it's the factored version of x plus 3, x minus 3, and x plus 2. If I multiply these together, we end up with x squared minus 9, because x plus 3 times x minus 3 is x squared minus 9 times x plus 2. It'll be x cubed plus 2x squared minus 9x minus 18. Okay, that's the original function. But it's so much easier to work with that factored form, which is what we have here on the left. Now, if I follow up and say, hey, what are the possibilities of making this go to 0? So for what values of x would make this large polynomial equal 0? When will this equal to 0? So when will 0 equal to x plus 3, x minus 3, and x plus 2? And as you guys worked on the last homework, this is pretty easy because we just solve for each of these individual problems, making them each go to 0. And that's what the zero product property talked about. And we learned that in Algebra 1, is that if I multiply anything by 0, all the other values go to 0. Let me give you an example. If I solve for this as negative 3, x is equal to negative 3, x here is equal to positive 3, and x is equal to negative 2. If I plugged in negative 3 to this problem here, 3 minus 3 is 0, and 0 times any other number, no matter what this would have been, and even if we try solving it, negative 3 minus 3 is negative 6, and negative 3 plus 2 is negative 1, times this by 0 in the front. Remember we said that was going to be 0 in the front. 0 times anything is 0. 0, 0, so we end up with 0. We can do the same thing with if I plug in negative 3. If I plug in, positive 3, our next answer here. If I plug in positive 3, this would have been 0, and 0 times anything else would have been 0. So we have three possibilities to solve here. We have negative 3, comma 3, and negative 2. Now we demonstrated this in our last class, that these answers, negative 3, would also make the original polynomial go to 0, because these are equivalent statements here. Whether I write it as a factored form, or the original polynomial, they're both equivalent statements. And if I plug in negative 3, let's just do it here to just prove it to you one more time. And again, do you really want to do this? You don't. You want to understand that if I did plug it in, because the factors showed that it was going to be a 0, we were going to be good anyway. So let's go ahead and just make sure. This is negative 27. This over here is 9 times 2 is 18. 3 times 9 is 27, so that's positive 27. And then minus 18, as you can see, negative 27, positive 27, and positive 18 and negative 18, they all cancel out to become 0. Right? And hopefully you don't need me to demonstrate, but if you try it with the 2 and the negative 2 also, that would also give us a 0. So what do these x equals to 0 mean? Or x leads us to 0? These are what we call roots. And these state themselves in the graph as the zeros of the graph. If I plug in negative 3, negative 1, 2, 3, negative 3, 1, 2, 3, positive 3, and negative 2, the graph would actually have zeros and negative 3, negative 2, and 3. Meaning the graph would go through these points here. Maybe not this way, maybe the other way. But the graph would for sure intersect the x-axis at these points. And now once we have our checkpoints, you could say, if you guys ever play a video game, oftentimes you have nav points or checkpoints. These checkpoints tell us kind of what the path has to go through, which saves us a lot of time. And this is a rough graph. But know what? This is good enough for us. And that's the skill that we're aiming toward. We're going to be able to look at the factored equation, find the roots of it, and then that'll lead us to what the graph would look like. In really, like 30 seconds. Okay. All right. So let's look at another problem here. And we're going to ask ourselves what the roots are. So if I say f of x is equal to x plus 3 squared x minus 4. Okay, what are the roots here? What would make this go to 0? And when I'm saying, when you hear the word roots, you're thinking y is equal to 0. That your function f of x is going to be 0. So when x plus 3 squared x minus 4 When will this equal to 0? Well, the answer is going to be x is going to be -3 and +4. We could write this out if you want. You could say x plus 3 is equal to 0 minus 3 minus 3, and x minus 4 is equal to 0 plus 4 plus 4. But hopefully, mental math, x is -3 and x is +4. But this is what we're really doing. So the roots are what would make the problem go to 0. Because just like the roots of a tree, the roots are where the plant touches the ground. Okay, yes, there are other roots. Yes, yes, yes. But this is a very simple idea of where we get this terminology from. Okay, so to include this, you look here and you only see 2 roots. Okay, and if I told you we had 3 roots, but you only see 2 numbers, we have to include some more information here. And the word we mentioned last time was multiplicity. And the multiplicity of -3 here is 2. The multiplicity is 2. And the multiplicity of 4 is 1. So x at -3 has a multiplicity of 2, and x at 4 has a multiplicity of 1. Now this tells you how many times those roots occur. How many times, even though I gave you only 2 answers of -3 and 4, I still told you the number of times the root occurs, which means those are also the number of times we have to write the factor. Now here is our reverse method now, meaning what if I give you the roots? Now let's start here. I told you the roots are going to be -3 and 4. I also included some information about the multiplicity and how many times this occurs. So at -3, this happens twice. So to give us the factor, we can say, okay, if -3 is my answer, what did I cancel out? Well, I canceled out a +3. So x plus 3, right? That becomes our variable. At x plus 3, that is a root for me. Leading back to our original factor. Take a look up here, that's our original factor. If x is 4 now, 4 plus minus 4, when do they cancel out to give me the 0? So it's x minus 4. We also said that the multiplicity was 2 for -3, and that's where we're going to go ahead and include this square here. And this is our original function, with the roots -3 and 4. So today in your IXL, you guys are going to write first looking for the roots. What are the roots given a factored problem, which should be pretty easy. Us going backwards will take a little bit of work here, because what they want us to do is not only work backwards and write the factors, but now multiply it out. So for our next step here is we're going to go ahead and multiply x plus 3 times x plus 3 times x minus 4. Now I want to show you the fast way of doing this and the traditional way. Now we had a fast way of squaring a binomial, and if you remember that, this is going to be square the front, square the back. That's why it's a 3 times 3 is 9, and double the middle. 3x is going to be 6x. Okay. If you need to write it out, we just go x plus 3, and we go x times x times 3, x squared plus 3x, 3 times x, 3 times 3, 3x plus 9. We have like terms here, x squared plus 6x plus 9. Again, if this was a squaring a binomial, hopefully you can remember the fast identity to get there. Square the front, square the back, and double the middle. In the back, we're going to go ahead and multiply x minus 4 to this. So I'm going to take my time. I'm going to go the other way, x to make that fast, and then -4, -4, -4. And I'll write that in 2 rows. X squared, x times x squared is x cubed, x times 6x is 6x squared, x times 9 is 9x. Now I'm going to multiply the -4. I could write it over here, but to make it easy on my brain, I'm going to write it over here where I can match like terms. -4 times x squared, -4x squared. Negative 4 times 6 is negative 24x. And 9 times negative 4 is negative 36. We can go combine like terms now. X cubed plus 2x squared minus, that's a 24, right? That's going to be 15x, and then minus 36. And this is our original function, our original polynomial. And that's what we're expected to write in IXL. So we'll do this one more time, going forward and backwards. And just to prove to you that just because we have a little bit of time, I'm going to plug in the 4 into the problem, and we'll see, does it give us a 0? Remember we said negative 3 and 4 are the roots. So 4 cubed plus 2, 4 squared minus 15 times 4 minus 36. We have 4 is 64. 4 times 4 is 16 times 2 is 32. Minus 60 minus 36. We're going to add these up to become, this is 96, negative 96. And this does give us a 0, like we hoped for. Okay. Let's do one more problem since we're here. If I told you let's go, here are the roots. And the roots are 0, 1, 2, and 3. Okay, 0, 1, 2, and 3. Now, this 0 is a trick here, and it's actually an easy trick. And hopefully you remember, if it's a 0, we have an x by itself. Now, you could write x minus 0, right? Just like the other terms. Look, you could write x minus 1, x minus 2, and x minus 3. Because 0 minus 0 is 0, 1 minus 1, 2 minus 2, 3 minus 3. That would give us our factors. But please, from now on, to save yourself time, whenever you see a 0 as a root, just write a free x floating around. Because x minus 0 is really just x. Then that will save us a lot of time. And then the next trick here is, since x is so easy, we'll save that for last. Okay, this will be last. And we'll just multiply the other ones first. So we have x. Over here, this will be x squared. In the back, there'll be plus 2. And just to show you, negative 1x minus 2x is negative 3x. Save ourselves some time. X minus 3. Multiply these together. I'm going to multiply these together right here. I'm going to leave the x on the outside. We'll worry about that in our next step. So we'll have x cubed minus 3x squared plus 2x, because I'm multiplying by x, x, and x. So that's fast. I just give everyone an extra x. And then we're going to give everyone a negative 3. Negative 3x squared plus 9x minus 6. Okay, so what we're left with over here is x cubed minus 9x squared plus 11x. Oops, sorry, I multiply instead of just adding. That's negative 3 is negative 6. 2 plus 9 is 11, and negative 6. Then we're going to multiply everyone by x. X to the 4th minus 6x cubed plus 11x squared minus 6x. And this is the polynomial with the roots, as you mentioned, as 0, 1, 2, and 3. And the multiplicity of each of these roots is 1, because we only saw each of these once. Multiplicity of 1. Okay. Now, I'm just going to go ahead and pick one of these numbers. Actually, a couple of them. If I pick 0, 0, 0, 0, 0, yep, that for sure was going to work. Now I'm going to try just 1. 1 minus negative 6 times 1 is negative 6. I'm plugging in 1 again. Plus 11 times 1 squared is just 11. And minus 6. So let's see if this is going to give us a 0. 1 and 11 is 12. 6 and 6 is 12. And this gave us the 0 we were hoping for. Okay, so this function, this x to the 4th, is the same answer as us writing this in factored form. And this is the solution, has the solutions of 0, 1, 2, and 3 for its roots. And that's really what your work is today. Cool. Thank you very much.